In 2001, the Rolex Foundation, which awards what many engineers consider the most prestigious prize for practical human innovation on Earth, gave its top award to a schoolteacher from northern Nigeria. Not a professor, not a research scientist, not an engineer with a doctorate. A schoolteacher, not someone with access to a university laboratory, not someone with research funding or institutional support or a team of graduate students running controlled experiments. A schoolteacher in northern Nigeria who looked at a problem his community faced every single day and solved it with 2 clay pots and wet sand. His invention had no battery, no solar panel, no refrigerant, no circuit board, no moving parts. It cost $3 to build from materials available in any market in the developing world. No proprietary components, no supply chain dependency, no manufacturer warranty, no planned obsolescence, no replacement parts, no service interval, no electricity requirement, no infrastructure requirement of any kind. $3. Available everywhere, requiring nothing after the moment of construction. It kept tomatoes fresh for 27 days without electricity, in a desert, in 44°C heat. 27 days, in conditions where the same tomatoes left in open air spoiled within 2 to 3 days. A tenfold extension of usable food life. In a region where food insecurity was not an abstraction, where the difference between adequate nutrition and hunger was measured in exactly those days of preserved freshness that the Zeer pot provided. His name is Mohammed Bah Abba. If you're watching this video in the United States, I am 99% certain you have never heard of him. Not because his work was obscure, not because the Rolex Foundation's recognition was minor or regional, not because the validation of his invention was incomplete or contested, because the information infrastructure of the American consumer market, the media, the retail system, the manufacturing and distribution networks, had no financial incentive to make you aware of a $3 invention that required nothing from any of them after the initial purchase. That is what this video is about. Plant the question. Clear. The question must land completely. 100 million people use some version of Mohammed Bah Abba's invention right now. The physics behind it has been known since ancient Egypt. The Rolex Foundation validated its performance at scale in 2001. The University of Warwick published updated data in 2023. 100 million people, not in a single country, across sub-Saharan Africa, the Middle East, and South Asia, across 17 documented countries, in daily use, right now, by 100 million human beings who depend on it for food preservation, for the reduction of post-harvest losses, for the margin between adequate food and spoilage that determines whether families eat or do not eat. And in every American hardware store, in Arizona, Nevada, New Mexico, California, Utah, states where this device would work better than almost anywhere on Earth, it is not on any shelf. Not in the camping section, not in the garden section, not in the emergency preparedness section, not as a specialty order, not as a seasonal item, not as a curiosity product in the artisanal goods aisle, not anywhere. In states where summer humidity averages 12 to 16%, conditions that maximize the evaporative cooling performance of this device beyond almost any other location on the planet, the device is absent from every retail environment that serves those states. This video is going to answer one question, not why it is unusual, why no American company has ever attempted to bring it to market in the 50 years it has been documented and validated. What that tells you about the market. The physics of evaporative cooling. Professorial, confident. Build the physics clearly. The 30 degrees number, pause before it and after it. The physics exploits one of the largest energy transfers in all of thermodynamics, the latent heat of evaporation. When liquid water transitions to water vapor, it requires energy, specifically 2,260 joules per gram of water evaporated. That energy must come from somewhere, and in the Zeer pot, it comes from the thermal energy of the sand surrounding the inner clay vessel. As water evaporates from the sand, it draws heat from that sand. The cooled sand draws heat from the inner pot through conduction. The pot cools. Its contents cool with it. 2,260 joules per gram. To put that number in context, Heating the same gram of water from 0 degrees to 100 degrees Celsius requires only 419 joules. Evaporating it requires 5 times more energy than boiling it. That energy has to come from somewhere. In a Zeer pot, it comes from the thermal mass of the surrounding sand. The sand gives up its heat to drive the phase transition. The contents of the inner pot benefit from the resulting temperature drop. The efficiency of this process depends on air humidity. In desert conditions below 20% humidity, the conditions in Phoenix, Las Vegas, Tucson, and Albuquerque during summer, the theoretical cooling achievable is between 18 and 24 degrees below ambient air temperature. Below 20% humidity, the atmosphere has significant remaining capacity to absorb water vapor. Evaporation proceeds rapidly. The energy transfer is large. The cooling effect is pronounced. Phoenix averages 12 to 16% relative humidity during peak summer months. Las Vegas averages 10 to 14%. These are not marginal conditions for evaporative cooling. These are optimal conditions. The Zeer pot, deployed in Phoenix, Arizona, in July, operates in conditions that approach the theoretical maximum of its physical cooling potential. The University of Warwick published experimental data in 2023 measuring optimized Zeer pot performance in conditions replicating northern Nigerian summer. Exterior temperature 42 degrees Celsius, humidity 18%. Interior pot temperature 11.3 degrees Celsius. A 30-degree temperature differential, with wet sand and 2 clay pots. It requires electricity to run the pump and the distribution fan. It requires annual maintenance. Filter replacement. Winterization. Over its 12 to 15-year service life, total cost of ownership, $4,000 to $8,000. $4,000 to $8,000. Over the service life of a device that performs the same physical process as a $3 clay pot. The additional $3,997 at minimum does not purchase superior physics. The physics is identical. It purchases a motor, a pump, a fan, a filter system, an electrical connection, a maintenance schedule, a replacement cycle, a recurring revenue stream for the manufacturer, the installer, the part supplier, and the utility providing the electricity to run it. The Zeer pot achieves the same physical process with no electricity, no motor, no filter, no maintenance cost, and a service life measured in decades. Decades, not 12 to 15 years. Not the replacement cycle that drives recurring appliance revenue. A well-constructed, unglazed clay pot does not have a designed obsolescence point. It does not have a compressor that fails. It does not have a pump seal that wears out. It does not have a motor winding that burns. It has clay and sand. Clay and sand do not have failure modes on a 15-year cycle. The companies that manufacture and distribute evaporative cooling equipment in the United States generated approximately $900 million in residential product revenue in 2024. Not one of those companies has ever introduced a passive clay pot cooling product to the American consumer market. Not one has ever funded a study comparing passive clay pot cooling to powered evaporative systems. Not one. $900 million in annual revenue, built on a powered version of a physical process that works without power, sustained by a consumer market that has never been offered the passive alternative, protected by a retail environment that stocks the powered version in every relevant section of every relevant store in every relevant state, and has never stocked the $3 version that operates on the same principle. The suppression. The American refrigerator and cooling appliance market generates approximately $22 billion in annual retail revenue. The average American household replaces a refrigerator every 12 to 15 years at an average cost of $800 to $1,200, plus the electricity cost of running it, averaging approximately $150 per year over its lifespan. $150 per year in electricity. Every year, for 12 to 15 years. Then a replacement purchase, then another 12 to 15 years of electricity costs, then another replacement. This is not a product sale. This is a subscription relationship with a capital purchase attached. The appliance industry's revenue model depends on the cycle, continuing without interruption, without a consumer ever receiving, evaluating, or choosing an alternative that breaks the cycle permanently with a $3 one-time purchase. In Phoenix, Arizona, where average summer relative humidity is 12 to 16%, the theoretical evaporative cooling potential is among the highest on Earth. In those conditions, a modern optimized Zeer pot maintains interior temperatures at or below 15 degrees Celsius during peak afternoon heat. Phoenix is not an edge case. It is the center of the American evaporative cooling market. 2 million homes with rooftop swamp coolers. A retail environment full of powered evaporative cooling products. A consumer base that is already using evaporative cooling physics daily and has never been offered the passive version of the same physics at $3 per unit. No Home Depot, no Ace Hardware, no True Value, no Amazon Basics line. No American manufacturer or retailer has ever listed this product for the American consumer market. The economics of the American appliance industry are built on replacement cycles. A refrigerator fails after 12 years and must be replaced. An evaporative cooler fails after 15 years and must be replaced. A Zeer pot built from locally sourced clay and sand lasts 30 to 50 years with no mechanical components to fail. It does not generate a replacement cycle. It generates a $3 one-time purchase and then nothing. Nothing. That is the word that explains its absence from every American hardware shelf. Not nothing as in no value. Nothing as in no recurring revenue. Nothing as in no replacement sale in year 13. Nothing as in no service call. Nothing as in no filter subscription. Nothing as in no electricity meter running. An industry built on replacement cycles does not voluntarily introduce a product whose primary commercial characteristic is that it never needs to be replaced. The proof plus DIY. Mohammed Bah Abba died in 2010. His invention is in daily use across sub-Saharan Africa and South Asia. He died in 2010 with a Rolex Award, the UNESCO documentation, the UNICEF distribution partnership, and 100,000 pots in Jigawa state. The American consumer market had not acknowledged his existence. It still is not. If you want to build one today, and in the American Southwest you should, the materials are 1 large unglazed clay pot, 1 smaller unglazed clay pot, clean sand and water. Place the smaller pot inside the larger. Fill the gap with sand. Keep the sand moist by adding water twice daily. Place in a shaded location with air circulation. In low humidity conditions, interior temperatures will reach 10 to 15 degrees Celsius on summer afternoons. The construction takes 10 minutes. 10 minutes. That is the total labor investment required to build a food preservation device that maintains 10 to 15 degree interior temperatures in Phoenix summer heat. 10 minutes of construction time. 2 clay pots from any garden center. Sand from any landscape supply yard. Water from any tap. No instruction manual beyond what was just stated. No tools. No permits. No licensed installer. No manufacturer warranty card to mail in. 10 minutes and $3. Unglazed clay pots are available at any garden center. The materials cost $3 to $8 total. Conclusion. Calm, philosophical. Falling intonation throughout. End flat. $3. 2 clay pots. Wet sand. A physics principle documented since ancient Egypt. A schoolteacher who won the world's most prestigious engineering prize. 100 million current users on 4 continents. And not a single unit available in the hardware stores of the states where it would work best. Not a single unit. In the optimal climate. In the world's largest consumer market. In the states where the physics would perform closest to theoretical maximum. In the stores that stock the powered version of the same physical principle in every relevant aisle. Not one unit of the $3 passive alternative. Because the $3 passive alternative does not generate a replacement cycle. That is a market working exactly as designed for the companies that designed it. Subscribe, because the last video in this series is the one that ties every previous video together. A wall material commercially available in Europe since 2005. Sold by an American company. To European builders. Never offered to American builders. We name the company. We show the product. We show exactly where in the financial structure the decision was made. Subscribe now. That video is next.